in 9.3, what we're going to be talking about in this section is what the graph of an exponential function looks like. And an exponential function is when the x of your function is in the exponent. Okay, we're actually going to skip 1 and 2 and come back to those in a little bit. Let's first of all just look at number 3 to see what the graph of an exponential function looks like. So it says to graph this on paper and then choose the correct graph. So y equals 2 to the x power. So again, an exponential function is when the x of your function is in your exponent. Okay, so let's plot some points from this function. Okay, again, we can go ahead and put this in our y equals, right? So we'll just go to my y equals and clear out whatever's in there. And then you're going to type in 2 to the x power. So again, 2, and then remember that little up arrow to go up into your exponent, and then put the x in your exponent. So let's graph that and look and see what it looks like. This is what the graph of an exponential function will look like, okay? So I'm going to actually plot some points on this. This is a multiple choice question, so only one of those actually have that shape. Okay, but let's look at what happens. I'm going to get a second table and plot some of these points. Okay, so I'm just going to make this chart from the table in my y equals. So let's see, when x is -3, the y is 0.125. When it's -2, it's 0.25. -1 is 0.5. 0 is 1. 1 is 2. 2 is 4. And 3 is 8. So let's plot these points and see why the shape of an exponential function is what it is. Okay, so the first point is at -3.125, which means go to the left 3 and then go up just a little tiny bit, right? So to the left 3 and then barely up at all. To the left 2 and still barely up any. It's a little bit higher than the last one. To the left 1, up 1/2. When the x is 0, the y is 1. So left and right 0, up 1. Now watch what happens on the other side of the y-axis. This says to go to the right 1 and then up 2. So right 1, up 2. To the right 2, up 4. So right 2, up 4. And then to the right 3 and up 8. So when you get to the other side of the y-axis, if you've heard the phrase that something is growing exponentially, look what happens. That's what it's talking about. It's growing very steep. So this one, it shoots straight up. Now here it comes down all the way to that x-axis, but it doesn't ever cross it. Okay, so that's what the graph of an exponential function will look like. Okay, number 4 on the sheet is actually the same exact problem. So I'm just going to erase this just to give another example to see what happens when this number changes. Let's just say it's 5. So still going to do my XY chart. So I'm going to put 5 to to the x power in my y equals and see what that looks like. Again, it's going to have the same shape. It's still an exponential graph. So if I do 5 to the x and then graph it, again, it's still taking on that same shape. It's just actually going to be steeper because look at this one's table. So second table, let's type in some of these numbers. So I'll do the same ones. So this time when the x is -3, the y is 0.008. -2.04. -1 is 0.2. 0 is 1 again. But then look what starts happening. The 1 is 5. 2 is 25. And 3 is 125. So that's what's making it go steeper. So again, -3.008. So this number right here, again, it's just constantly getting closer and closer to the x-axis, but it's actually not ever going to cross it. It's just going to get all the way up next to it. So to the left 3, and again, barely up at all. To the left 2, up 0.04. To the left 1, up 0.2. And again, it's got the same point as the last one, 0, 1. So left and right, 0, up 1. To the right 1, up 5. But then look what happens when your x is 2, your y is 25. So to the right 2, and you're already up to 25, which is already going off the charts. And then once you get to 3, you're up above to where we can even see, right? So that's why this one's actually a lot steeper than the last one because of this 5 right here instead of 2. That's what's making the curve be steep. So when this number right here, the absolute value of it, which means how far away from 0, is greater than 1, your exponential shape is going to take this shape. Okay, but look at number 5, where you have y equals 1/3 to the x power, which means the base of it, and the base of it is this number right here, the number being raised to the x. If the base number is less than 1, so a fraction that is less than 1, let's see what the shape of it will be. So again, I can go to my y equals, type in 1/3 to the x. Okay, I'm not 100% sure if the 1/3 has to be in parentheses, but I'm just going to put it in parentheses since it's a fraction. So 1/3, go up into my parentheses, go up into my exponent, put the x. Now look at what shape this one has. It's the same kind of shape, but it's reflected across the y-axis, right? And let's look at the reasoning for that. So by going to second table, let's look at some of these points. Okay, so let's look at what these look like. So you'll notice that if this number is greater than 1, it's going to have this shape. So this one is less than 1, which means it's going to have the same shape, but the actual steep part of it is going to be on the other side of the y-axis. So let's plot these points. Okay, so to the left 3, up 27. So it's somewhere way up here. To the left 2, up 9. To the left 1, up 3. Then 0, 1. So left and right 0, up 1. And then once it crosses here, now is when it's going to get all the way up next against the x-axis. So 1, and then up a third. So to the right 1 and up a third. To the right 2 and barely up at all. So again, that's what happens when the base of the exponential function is the absolute value of it is less than 1. Okay, now let's go back to 1 and 2. And these two are actually just calculator problems. So let's look at where this E button is on my calculator. Because these are just going to be calculator problems. Okay, the E button, if you'll look on your calculator, it's the LN button that's right next to the 4, but it's the blue, right? Which means to get to the E function, you're going to need to hit the second key and then hit the LN button. Then you'll notice it gives you the E and it automatically gives you that exponent. Okay, so on number 1, it wants to know what E to the 6th power is. So just put 6 up in your exponent and hit enter. And then it's just going to want you to round that decimal to 4 decimal places. Okay, the E, we're going to actually use the E in later on sections when we talk about compounding interest continuously and some real life examples of compounding interest. The E is used in that situation. So this is just getting us used to finding it on the calculator. So rounding it to 4 decimal places. So you're actually going to want to see 5 decimal places, right? Because the 4th decimal place, 4 numbers after the decimal, means you want to stop it right there. So you always look to the very next number, and if it's 5 or greater, that means you will round that 4th decimal number up 1, right? So that'll end up being 403.4288. All right, number 2 is the same exact kind of problem. So it's E to the negative 3.45. So again, you'll just hit the second button, then hit the LN button for the E, and then type in the number into the exponent. So negative 3.45. And again, it wants me to round it to 4 decimal places. So I'm going to write out 5 decimal places. So 0.03174. So this time, the 5th number is a 4, so it's not 5 or greater, which means I just don't need to round up that 7. So 0.0317. All right, number 6, f of x equals 6/5 e to the x. So this one, again, we're still graphing these exponential functions. It's just this one has an e in it. But now we know where that is on the calculator. So again, I'm just going to go to my y equals and then use my table function. So y equals, I'm going to put that 6/5 in parentheses. So open 6/5 close. Then my e, so second, then the ln button to get the e. And again, since it's an exponential function, the x is going to be in the exponent. And then we'll graph it. So on this one, there's actually two in the multiple choice that look similar to this. So let's look at some of these points by going to second table to see if I can find a distinguishing point. Which looks to me like the distinguishing point to be able to choose between B and C is going to be where this graph crosses through that y-axis. Okay, that's going to be the one that you're going to be able to tell which one it is. So let's look here. Let's just start with -2, -1, 0, 1, and 2 this time. 0.164. -1 goes with 0.44146. 0 goes with 1.2. Again, that's going to be your y-intercept. That's going to be the one that's actually going to be able to distinguish between the two. 1 goes with 3.2619. And 2 goes with 8.8669. All right, left 2, up 0.1624. Left 1, and up kind of close to a half. Again, here's the distinguishing one. Left and right 0. It's going to cross through the y-axis at 1.2. Then to the right 1 and up a little above 3. And right 2 up almost to 9. So again, you're looking for the one that has the exponential shape that's crossing the y-axis a little above the 1. And on this one, it's actually below the first hash mark though, right? Because what do the hash marks on this problem go by? They're going by 2s. Okay, so you just got to watch out for that. So it's going to cross through below that first hash mark since those hash marks are going by 2s. All right, 7, 8, and 9. We're still going to be talking about these exponential functions. Now, remember those transformation rules, the numbers that shift you left and right and up and down. Right? The inside numbers are going to shift you horizontally, but you're going to go opposite that sign. The outside numbers are going to shift you vertically up and down, and you're going to go with the sign. So let's think about where the outside and inside numbers of an exponential function are. Okay, before we get to that next one. The numbers that are inside the exponent are the inside numbers. So inside numbers shift you left and right, but you go opposite the sign. This number out here, that's your outside number that shifts you up and down, and you go with the sign. This number is called the base of the function. All right, so let's look at number 7. So, well, I guess just to continue with this example. So the inside number would shift you left and right. You go opposite the sign, so this one would actually shift you to the right 4. The outside number shifts you up and down, but you go with the sign, which means that one would shift you up 7. All right, so let's look at number 7. We have f of x equals 2 to the x minus 3. Okay, it's going to ask you about it's going to ask you what is the base of the function first. So the function that you're starting off with is going to be 2 to the x power. So you're starting off with 2 to the x. That's what's giving it that exponential shape. This is what's going to shift it. So since it's in the exponent, that's an inside number, which means it's going to shift me horizontally, but opposite the sign, which means it's going to shift it to the right 3. Now, this is like that section that we did on transformations. When you do this graph, you'll come over here to the exponent or to the toolbox, and you'll choose that x. You're going to tell it that you're going to want to graph an exponential function. Right? It's got the u parabola, it's got the x cubed over there, it's got the absolute value v. Well, it's also got this exponent, it's called the exponential tool. Then you're going to put that, you can click anywhere here. And then it's like those ones, it's going to give you the box down there, which tells you where to do your shifts. Okay, so you'll just shift it horizontally to the right 3. Now, something else that'll drive you crazy on this problem and the other one, it's also going to have in this shifting box, it's going to say base, but instead of it being blank, it's going to have an E in there. It's like that's the default, is that the base of the exponential function is an E. So you're going to have to actually go in here and delete that E, because the base of this function is 2. Okay, and you'll notice that it barely even moves the graph at all, because E actually is like, it's not far from 2. So it barely even moves the graph at all, but the base of this function is not an E, it's 2. So make sure you change the base of your problem to a 2. Right, number 8. All right, same kind of problem. F of x equals 5 to the x minus 4. So again, you're starting off, what's giving it its shape is that 5 to the x power. With the x in the exponent. Now, this is an outside number. which shifts you up and down, go with that sign. So it's actually going to be down 4. And then again, it's going to be one of those transformation graphs where you're going to go in and you're going to tell it that you want to graph an exponential function. Then you'll tell it to shift vertically down to -4. And once again, the base in that box down there is going to be E. So make sure you change your base this time to 5. Which is another problem like this. It's just got an inside and an outside number. F of x equals 2 to the x plus 4 minus 1. Okay, so on this one, again, you're starting off with 2 to the x power. And this one has 2 shifts, right? It's got an inside number shift. So I'm going to go opposite that sign. So to the left, 4. And my vertical shift is down 1. So that'll shift it. And again, make sure you change your base to 2. All right, the last 2 problems are actually using real life scenarios of exponential functions. Okay, the formula that we're going to use for both of these is A equals P times 1 plus R over N to the NT. So let's see what all this is. Okay, so the A in this formula is going to be the amount that you're going to end up with after your investment has been invested for a certain amount of time. The P, which is the principal, that's the initial amount that you are putting into the investment. The R is going to be what the interest rate is. Now, they're going to give us the interest rate in a percentage form, and we're going to have to turn it into a decimal form. The N is the number of times it's compounded, the investment's compounded per year. So if it's compounded quarterly, that would mean 4 times a year. If it's compounded semi-annually, that would mean twice a year. Okay. The T is the number of years that your investment has been invested. Okay. So let's look at number 12 and see what the information is that they give me. So it says, suppose that $87,000 is invested, which means $87,000 would be your principal. That's the amount of money that you are starting off with. At 5.5% interest. So the interest rate is 5.5%, right? That's 5.5. Now, in order to use this formula, this has to be changed to decimal form. When you're going from a percentage to a decimal, you're going to move this decimal 2 places to the left. And then you're going to fill in that hole with a 0. So the interest rate in decimal form is going to be 0.055. Then it says invested at 5.5% interest, compounded quarterly, which means the number of times it's compounded per year is 4. Now, this is what's going to change, right? This is going to be your answer, right? Once I get it all figured out, the end amount is going to be your answer. This is what's going to change, because what's changing about the problem? Not the amount of money that you're investing. That's a set number. The interest rate is a set number. This number of times it's compounded is a set number. The number that always changes is the amount of years that your investment has been invested. Okay, so the first part of this problem just wants you to come up with what would the formula be. So let's put in what I know. So let's see, instead of this P, I'll put 87,000. Open parentheses, 1 plus my rate in decimal form is 0.055 over my N is 4. My N again is 4. T is what is going to change all the time. So I'm just going to keep that a T right now. Now, this essentially is the formula. Now, what it wants you to do before you put that answer into MATLAB is turn what's inside this parenthesis just into one number. Okay, so I'll have 87,000. Now, I'm just going to put this in my calculator. 1 plus 1 plus 0.055 over 4. So inside that parenthesis, I'll have 1.01375. To the 4T. So that's going to be the formula that answers the A part of this. Now, the second part of this question says, okay, how much money in the account at 0 years? So again, what's changing on all the rest of it is what you're putting in that T spot. if I put 0 there, what does that change the exponent to? 4 times 0, which is 0. So now I have 87,000 times 1.01375 to the 0 power. That's what you're going to put in your calculator, exactly how it's written. So 87,000, open parentheses, 1.01375, close, and then go up into your exponent. And in your exponent, you're going to put 0 and enter. So what did that tell you? 87,000, which makes sense, right? You literally have not had the money in there at all. You just put it in. 0 years, right? So that would be 87,000 after 0 years. Then the next one says, what about after 3 years? So again, what's changing? This T right here is changing to a 3, which means the exponent now changes to a 12. So again, you're just punching that in your calculator. 87,000, open parentheses, 1.01375, close. This time when you go up into your exponent, you're going to put your exponent as 12. Enter. And it wants us to round it to the nearest dollar. So again, I went one space further, right, than it asks you to show to see that this 9 does what? It needs to round this 1 up to a 2. Okay, so instead of 491.9, you're going to have 102,492. Right, and then we'll just do one more. What about after 7 years? Again, the only thing changing is that T is now 7 years, which means now your exponent is 4 times 7, which is 28. And then I'll punch that in. So 87,000. Open 1.01375, close. This time going up into the exponent, it's 28. And again, rounding it to the nearest dollar. So since it's 0.5, that's going to round that last 1 up to a 2. Right? So I'll have 127. 5.2. Okay, and then it just has one more for 10 years. So you're just obviously just going to change that to a 10, which changes your exponent to a 40. And then do the same thing. All right, last one. Number 13. All right, on Melissa's 6th birthday, she gets a $5,000 CD. So $5,000 is the original investment. That earns 6% interest. So the interest rate is 6%. percent. So if I change that to a decimal, right, so it'll be 0.06. Compounded semi-annually. So the number of times, if you're compounded semi-annually, you're compounded twice a year. If the CD matures on her 11th birthday, how much money will be available? So she got it on her 6th birthday. It matured on her 11th birthday, which means how many years has it been invested? Right, it's been invested 5 years. From her 6th birthday to her 11th birthday. So let's plug all this in to see how much money she has on her 11th birthday. So let's see. My P is 5,000. 1 plus my interest rate is 0.06 over 2 for the number of times compounded, and then the exponent is, again, 2 times the 5 for the years. So let's see, 5,000. Let's see what that is inside the parenthesis. I've got 1 plus 0.06 over 2, which gives me 1.03. My exponent is 2 times 5, which is 10. So let's punch this in. 5,000, open parenthesis, 1.03, close. To the 10th power. And this time we are rounding to the nearest cent. So after that 58 is a 1, which means I don't need to round up 58 cents. So she ends up with $6,719.58.